Hi everyone, it's Miss Costa here, and in this video we're going to be going through the November 2018 Foundation Paper 1. So in the first question, I'm asked to put the numbers in order of size. And whenever you're ordering decimals, the best thing to do is put them in a list and then fill out any extra information. So I've got 0.4, then I've got 0.02, I've got 0.37, 0.152, and 0.2. Now people always get really confused with place value, so the best thing to do is to write them out like this and then fill out any other place value digits with zeros. That way you can just compare them a little bit better. So one method of comparing them, because they're all decimal points, digits after decimals, is to just literally look at it and imagine that they're after the decimal point, that they're numbers in their hundreds. So you know 400 is going to be the largest number. The best way to do it is to know that the tenths column is the column that has the highest place value, then there's the hundredths column, and then there's the thousandths column. But another way, as a little trick, is to just put them in order like that. So we look at the first decimal after the decimal point, and in this case it's the tenths column, so 4 is the largest value. They've actually asked us to put them in order starting with the smallest number, so let's actually do what they've asked. So starting with the smallest number, 0 is the smallest number in this column, so I'm going to write 0.02. Then the next smallest digit would be 1, so 0.152. Then we've got 2, so that would just be 0.2. Then we've got 3, so that would be 0.37. And finally, we've got 0.4. So people sometimes think that, for instance, 0.37 might be bigger than 0.4 because they imagine that the 37 is bigger than 4. And that's why it's helpful to just place in the place value holder, because it's not 37. It's 3/10 and 7/100, whereas this is 4/10, so that's actually the higher place value. So that's the best strategy for ordering decimals. Then we've got a decimal to a percentage. So to turn a decimal to a percentage, we simply multiply by 100. So this is a non-calculator paper, so 0.6, I'm going to have to multiply by 100. And a way to do that, if you're not super confident by multiplying by 100, is to multiply by 10 and then multiply by 10 again. So 0.6 times by 10. To multiply something by 10, we move it one digit to the left. We're multiplying it by 10, so it's getting 10 times bigger. So 0.6 times by 10 would become 6.0. And if I then times that by 10 again, that would become 60. I'm moving it one digit to the left in terms of the place value columns. So 0.6 as a percentage would be 60%. Next, I need to write down a factor of 10. So factors, they're numbers that multiply to make your given number. So for instance, the factors of 10 would be numbers that multiply together to make 10. Normally they come in factor pairs. So for instance, the factors of 10 would be 1 times 10. So 1 and 10 would be a factor, and 2 times 5. I could write them in a list, 1, 2, 5, and 10. But in here, all I'm being asked to is write down a factor of 10. So just any number in this list that multiplies to make 10. And in this case, that would be 5. Next, I'm asked to round. So I'm asked to round to the nearest 1,000. So what I need to do is circle the digit that's in the thousands column. So this is your ones column, your tens, your hundreds, and your thousands is the fourth place away from the decimal point, so the thousands column, and I need to round to the nearest 1,000. So what I'm actually doing is trying to decide whether 7,829 is closer to 7,000 or 8,000. Well, you know that halfway between 7,000 and 8,000 is 7,500, and that's why the rule applies that you circle your digit, you look next door. If your number is 5 or more, you know you're rounding it up. If it's 4 or less, you know you're rounding it down, so it essentially stays the same. So 7,829. I know that 829 is larger than 500, so I know it's going to be rounding up. So that would round to 8,000 to the nearest thousand. You look next door. If it's more than 5, you add 1 more to your circle digit, and then you leave everything else as it is. So that would become 8. You turn everything else to zeros. Next, we've got BIDMAS and indices. So with BIDMAS, you can do it like a little pyramid. So first you do anything that's in brackets, then you do anything that has indices. So brackets would be like, but we have no brackets in this. Indices would be things like 3 squared or the square root of 15. Then you've got division and multiplication on the same level, so you do them in the order that they appear. And finally, you've got addition and subtraction. So using BIDMAS, I have no brackets, I have no indices, I have no division, but I do have multiplication. So I'm going to need to do the multiplication first. So that's 15. I write everything else out as it is, and I do 15 plus 7, which is 22. Okay, next I need to work out 2 cubed. Now this little number here is called an indice, and all it means is how many times your number is being multiplied by itself. So 2 cubed means 2 times 2 times 2, means 2 is being multiplied by itself 3 times. So I do 2 times 2, which is 4, and 4 times 2 is 8. So 2 cubed is 8. Finally, I need to write brackets in the statement to make it correct. So I need to figure out which order I need to do things in order to get to 35. If I did 7 times 2 plus 3, well, 7 times 2 is 14, 14 plus 3 is 17. So I know that wouldn't work. So let's try something else. If I put the brackets in between the 2 and the 3, like that, that would end up being 7 times whatever 2 plus 3 is, 5. And 7 times 5 is 35. So I know that I'm going to need to put my brackets in here. If you're ever a little bit confused, just try out some variations and see which one works. Okay, so here I'm told that Sue has 2 cats and that each cat eats a quarter of a tin of cat food each day. I'm told that Sue buys 8 tins of cat food, and I'm asked if she has bought enough cat food to feed her 2 cats for 14 days. So there's quite a few ways that we can approach this question. I know she has 2 cats and that each cat eats a quarter of a tin of cat food each day. So if we just imagine this is the tin of cat food, and cat 1 would eat a quarter, cat 2 would eat the other quarter. So in total, I've got a quarter plus a quarter, which makes a half. Hopefully you can visually see that a quarter plus a quarter makes a half. So each day, her 2 cats need half a tin of cat food. So for 14 days, she'll need 14 times by a half. So when I'm multiplying fractions, all I do is I multiply the numerators and the denominators. If you have a whole number like 14, to turn it into a fraction, to turn any number into a fraction, let's say 3, you just write it over 1. So to work out how much you'd need for 14 days, I'm going to do 14 over 1 times by a half. So 14 times by 14 is 14. 1 times 2 is 2. And 14 divided by 2 leaves me with 7. So she will need 7 tins of cat food to feed them. And 7 is less than 8. So yes, she has enough. Now it's really, really important. If a question is asking you, does someone have enough money? Does someone have enough of this? You need to say yes or no. But it also says you must show how you got your answer. So you need to show your working out as well. If you only say yes and you only say no and there's no working, you're going to get no marks. Similarly, if you show your working but you don't have a conclusion, you're not going to get your conclusion mark. So it's important to show your working and say what you conclude based on your working out. Okay, next I've got a pictogram. I'm told there are only apple trees, cherry trees, pear trees and plum trees in an orchard. The pictogram shows information about the number of each of these trees, and I'm told that there are 30 trees in the orchard, and I need to complete the pictogram. So it's really important when looking at a pictogram to look at the key. I know that a full square represents 4 trees. So if I've got half a square, I know that's going to represent half of 4, which would be 2. So it might be helpful to just show myself what everything is. So I know that a square is going to be 4. Half a square is therefore going to be half of 4, which is 2. And if I get something like this, which is a quarter of a square, that is going to be 1, because that's 4 being split into 4 parts. So you're left with 1. So then I can start labeling what I already have. So I've got 4 here, 4 here, 4 there. So in total I have 4 plus 4, which is 8 plus 4, 12. So I have 12 apple trees. I have 4 here and 1 there. So I have 5 cherry trees. Then I've got 4, and this would be a 2. So that would be 6 pear trees. So I need to complete the pictogram. I know there are 30 trees in total. So if I've worked out how many there already are, I can work out what the missing plum trees must be. So 12 plus 5 plus 6. So you can just do the addition however you want. I would probably start by just adding the easiest number. So 12 plus 6 gives me 18. So I'm left with 18 plus 5, which is 23. So I know that there are already 23 trees here, which must mean that 30 take away 23 is 7. So I'm left with 7 plum trees. So how could I present 7? Well, I'd draw a full square, which is 4. And then 4 plus 3 makes 7. So I'm going to have to draw 3/4 of a square. And this is where pictograms get a little bit tricky, because some people might try and say, okay, I'm going to do 2 plus 1. But as a pictogram, you need to fill up the whole portion before you start another set. So you need to make sure you've got 3/4 of the shape. Okay, next I need to plot some coordinates and read some coordinates. So I'm told to write down the coordinates of point A. So when I read coordinates, I always go along the corridor, which is the x-axis, and then up or down the stairs, which is the y-axis. So I go along to where the coordinate is, which is -2. So my x-coordinate is -2. Then I go down to where it takes me on the y-axis is -1. So that's how I'd read this coordinate. Then I'm told to mark with a cross the point 2, 3. So I do a similar thing, go along the corridor to 2, and then up the stairs to 3, and I'm going to plot my point there. Whenever we plot coordinates, we always plot them with an X. And then I'm told to draw the line with equation X is -4. Now, whenever I'm drawing straight lines like this, a vertical or a horizontal line, my vertical lines are always going to be X equals lines, and my horizontal are going to be Y equals, and I'll explain in a second. So I need to draw the line X equals -4. Now that would be the line over here. And the reason for that is, if I pick any coordinate on this line, so let's just start over here. So this coordinate would be -4, 1. This one would be -4, 2. Here I'd have -4, 3. Here I'd have -4, 4. Here, for example, I'd have -4, -2. So every X coordinate along this line is -4. That's why I call it the line with equation X is -4. And that's how I do that. You don't need to obviously label all the coordinates. I'm just showing you what they are. So the straight line would just be over there. Okay, next I am doing some substitution. So I'm told that G has a value of 9 and H has a value of 4. And I need to work out the value of 2G plus 3H. So if G is 9, let's first of all think to ourselves what this algebra actually means. When a number and a letter are next to each other, it's it's implied that they are being multiplied. So there's this invisible algebraic multiplication glue that binds letters and number together. In algebra, it's just a shorthand way of saying multiplication. So 2g actually means 2 times by g, and then 3h means 3 times by h. So when I'm substituting my values in, that's what I need to substitute as well. So g, I know, has a value of 9, so that's going to be 2 times 9, and h has a value of 4. So h is going to be 4. So 2 times 9 is 18, and 3 times 4 is 12. So I know that 2g is 18, I know that 3h is 12, and I just add them together. So 18 plus 12, 8 plus 2 is 10, 1 plus 1 plus 1 is 30. So I know the value of 2g plus 3h would be 30. Now I need to write down 2 prime numbers that have a sum of 32. So prime numbers are numbers that only have 2 factors, 1 and themselves. So they only have 2 factors, 1 and themselves. So I can just start by writing out the prime numbers that I know. I know they're going to need to be numbers that are less than 32. So the first prime numbers, and these are things that you should know off by heart, are 2, 3, 5, 7, 11, 13, and the next few are probably numbers that you might have to think about, but these first few certainly you should know off by heart. Then we've got 17, 19, and it's most likely going to be some combination of any of these. The 2, just to remind you, is the only even prime number. And then any other number that is a multiple of 2, a multiple of 3, a multiple of 5, a multiple of 7, they're also not going to be prime numbers because they can be divided by 2, 3 or 5. So can any of these have a sum of 32? Well, let's just try by adding some. So I've got 19 here, which is quite a large one, and 13. Let's see what they come up to. 9 plus 3 is 2, 1 plus 1 plus 1 is 3. So the 2 prime numbers would be 13 and 19. You might have to go through a bit of process of elimination, or you could have also found a further prime number if we kept on going. So after 19, it's a little bit trickier, but let's just show you so that you know how to do it in case of another time that this happens. So what you do is you'd write out all of the numbers between certain values, and to eliminate prime numbers, what we do first of all, we eliminate anything that is a multiple of 2, because that means that aside from itself and 1, it's also going to be divisible by 2, so it cannot be a prime number because prime numbers only have 2 factors, which is 1 in themselves. So we can cross all of the even numbers out first of all. And then any number that is in the 3 times table, so I know 21 is in the 3 times tables, then you've got 21, 24, 27, 30, and so forth. Then anything in the 5 times tables, and then we're left with 23. So after 19, the next prime number would be 23 and 29. So you could also have combined 29 and 3. But 19 and 13 or 29 and 3 would be absolutely fine. They are only 2 options. Next, we've got some fractions, and I'm told that one of these fractions is not equivalent to 3/4. Which fraction? So what I need to do is see if I can simplify these fractions down to 3/4. So 9/12, how can I simplify that? If I divide 9 by 3, I can also divide 12 by 3. 9 divided by 3 is 3, 12 divided by 3 is 4. So this simplifies, so it's not that. 6/8, let's see what the highest common factor of that is. So I can divide by 2. So 6 divided by 2 is 3, 8 divided by 2 is 4, so it's not going to be this. Then we've got 18 over 24, so I could divide by 6. So 18 divided by 6 is 3, 24 divided by 6 is 4, so it's not going to be this. Then we've got 10 and 16. Now the highest common factor of 10 and 16 would be 2. So 10 divided by 2 is 5. 16 divided by 2 is 8. I can't simplify that any further. So 10 over 16 is not equivalent to 3/4. Just to prove it, 15 and 20, the highest common factor would be 5. So if I divided 15 by 5, I'd end up with 3. 20 divided by 5 is 4. Equivalent fractions, all it means is you divide the numerator and the denominator by the same number and you're simplifying it. And you continue doing that until you can't simplify it anymore. So that's the fraction that does not simplify to 3/4. Next, I have to add two fractions together. So the key thing that we need to remember about this is in order to add or subtract fractions, they need to have the same denominator. Okay, so they need to have the same denominator, which means you're going to have to turn one of them into an equivalent fraction so that it has the same denominator as the other. So you've got a 12th and you've got 5/6, and you want to think to yourself, what's the lowest common multiple of both of these numbers? So one way to do it is to write out those numbers times tables. So you've got 6, 12, 18, then you've got 12, 24, so forth. Now hopefully you noticed that 12 is in the 6 times tables, so 6 would easily multiply into 12. So I don't need to change this fraction because all I want to do is turn this fraction into a fraction out of 12. And I can do that by multiplying 6 by 2. And whatever you do to the denominator, you have to do to the numerator. So 5 times 2 is 10. And now that the fractions have the same denominator, you can just add them. So imagine that they're a piece of cake. So once they have the same denominator, we can just add them. Now we can imagine it's like a piece of cake. So if I had a cake that's split into 12 pieces, so 1, 2, 3, 4, 5, 6. So now we've got 1/12, which would be this little slice here, plus 10/12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In total, if you add them together, that's 11/12. So when we're adding fractions, once they have the same denominator, the denominator stays the same. It's the numerators that I add together because you've got one part of a whole. So you've got 1/12 and 10/12, and when you bring them together, some people sometimes add the denominators. You don't do that. The denominator stays the same. It's only the numerators that you add. Okay, next we've got a conversion graph. So I'm told that Tom uses his lorry to deliver bricks. You can use this graph to find the delivery cost for different distances. So this kind of question requires you to have a little bit of real life knowledge. So for instance, if you've ever got into a taxi, you might notice that it comes with, let's say, a £2.50 cost already, like you haven't even got in the taxi and it's charged you £2.50. That's called a call out charge. So even if you only go 1 mile down the road, it's still going to charge you that base rate of £2.50. It's just the initial charge that you're going to get charged regardless of how far you go. So we're told that for each delivery there is a fixed charge plus a charge for the distance. How much is the fixed charge? Now the fixed charge is the bit that never changes, so it's like your starting point. And what we can see from the graph doesn't start from 0. If it started from 0, then it meant that there would be no call out charge or fixed charge. But we can see that the graph starts here. It's between 0 and 20, exactly halfway. So that would mean that the fixed charge is £10. So the fixed charge or the call out charge is literally whatever the cost is before anything happens. So that would be £10 in this case. Now I'm told that Tom makes 2 deliveries of bricks. The distance of one delivery is 20 miles more than the distance of the other delivery. And I need to work out the difference between the 2 delivery costs. So what I could do is not told anything, so I can pick any 2 distances. So let's pick a nice and easy one. So over here I can see that if he drives 20 miles, the cost is £40. I'm told that the distance of one delivery is 20 miles more, so 20 miles more than 20 is 40. So for 40 miles, let's look at the cost. I go up to the graph. Oh, so when we're reading conversion graphs, I should have drawn that line as well. We go up to the graph and then across, and that's how we read them. So over here, I've gone up to 40, and then I go across, and that takes me to 70. So that would be £70. So using this conversion graph, I know that one delivery is 20 miles, the other is 40 miles. They're a distance of 20 miles apart. So I need to work out the difference between the two delivery costs. To work out the difference, you subtract the smallest amount from the largest amount. So I'd do 70 take away 40, which is £30. Okay, next I'm told that Asmal, Ryan and Kim each played a game. Asmal's score was 4 times Ryan's score. Kim's score was half of Asmal's score. Write down the ratio of Asmal's score to Ryan's score to Kim's score. So there's quite a few ways of doing this. I think the easiest way is to just use algebra. So we use algebra whenever we don't know the value of something. And we start with a person who we have no information about. So I know that Asmal, his score is 4 times Ryan's score. Then Ryan, I'm not really told anything about him. And then I'm told that Kim's score is half of Asmal's score. So Asmal divided by 2. So this seems a little bit complicated. So it's a lot nicer when we just bring in some algebra. So Ryan, I'm not given any information about. So I'm just going to call his score X. If Ryan is X, then Asmal is 4 times by X because his score is 4 times Ryan's score. So that would be 4X. And Kim's score is half of Asmal's score. So if Asmal's score is 4X, that would be half of 4X. So half of 4 is 2. So that would be 2X. Now, whenever I say X, it's like I say an apple. I don't need to say I want one apple. I just say I want an apple. So there's an invisible 1 whenever you have a letter like X or Y. So I need to write the ratio of Asmal to Ryan to Kim. So Asmal to Ryan to Kim, and I need to write it in that order. Whenever I do ratio, it's very important that you do it in the order that you're told. So Asmal would be 4X, Ryan would be X, and Kim would be 2X. And I said that Ryan would be 1X. So now all I want to do is turn that into ratio. So I can divide everything by X to get the ratio 4 to 1 to 2. So I've just divided everything by X to get it as just a numerical thing. You could also have, if you don't like algebra and it makes you want to cry and you just despise it, another way that you could have done it is just by giving Ryan an amount. So let's say Ryan is 1, then Asmal would be 4 times Ryan. So I do 4 times 1, which is 4. And Kim is going to be half of Asmal's score. So 4 divided by 2 is 2. So again, it would be Asmal is 4 to 1 to 2. Just sometimes it's a little bit more complicated. So algebra comes in a lot handier. Next, we've got some angles. And I need to show that ABCD is a kite. So in order to show that something is a kite, I need to know what the properties of a kite are. So the key properties of a kite are that you've got 2 sides here that are the same and 2 sides here that are the same, and you've got 2 angles that are opposite each other that are equal. So in order to prove this is a kite, I already know that AB equals AD. I've been told that. So what I'm going to need to do is work out the other angles and show that this angle and this angle are the same. So it is quite a tricky question if you don't know what the properties of a kite are, but you'd still be able to pick up marks just by working out, you know, different angles. So primarily, there are two main things that we can use here. So the first one is over here. Whenever you see angles like this, hopefully you remember what they are. They're called vertically opposite angles. So anytime two straight lines cross each other, then vertically opposite angles are formed. And the key thing about vertically opposite angles is that they are equal. So if vertically opposite angles are equal, that means that this angle, which is BCD, is going to also be 50 degrees. So first thing you could say is angle BCD is 50 degrees as vertically opposite angles are equal. And with angle reasoning, more than anything else, you absolutely need to state every single reason that you use. As it says, give a reason for each stage of your working. If you don't, you're just not going to get the marks. So now I know that's 50 degrees because of that reason. Then I can look over here and I know that this is a straight line, and hopefully you know that angles on a straight line sum to 180 degrees. So what I can do is figure out what this angle here is. So angles on straight line, I know sum to 180. So I'm going to do 180, take away 75 to figure out what angle ADC is. And the way I figure out what the angles are, I literally just follow the lines. So this one here I said was 50 degrees. So A to D to C, this is where the angle is. That's why I say ADC, because I go along the lines. So ADC is going to be 180 take away 75. 0 take 5 you can't do. 10 take 5 is 5. 7 take 7 is 0. 1 take nothing is 105. So I'd say angle, and this thing here means angle. So angle ADC is 105 degrees as angles on a straight line sum to 180. Okay, so I know that this is 105 degrees. And then finally, your last piece of reasoning would be to work out what angle ABC must be. And the way you can do this is, you know that angles in a quadrilateral, so any quadrilateral, which is a four-sided shape, sum to 360. So let's add 100 plus 50 plus 105 together first. So that would be 150 plus 105, and 105 plus 150 is going to give me 255. So because I know that angles in a quadrilateral sum to 360 degrees, I'm going to do 360 take away 255. So 0 take 5 you can't do, you borrow the 1, so 10 take 5 is 5, 5 take 5 is 0, 3 take 2 is 1. So I know that angle ADC is 105 degrees as angles in a quadrilateral sum to 360. Sum just means add up to. Now, even if you didn't know the properties of a kite, you still could have got all of these marks just by using your angle reasoning. So the final mark would be to say that angle ADC equals angle ABC, both are 105 degrees, and opposite angles in a kite are equal, and kites have two equal sides, therefore ABCD is a kite. So you've got each step for each angle that you've worked out, and the key thing is, you know, these two sides are equal and you know it's got two equal opposite angles where your two, so you've got your two sides here that are equal, and you've got your two other sides here, and where they meet, if the angles are the same, then you know that it's a kite. Okay, so in this question, I'm told that Shahid is going to use these instructions to make a fizzy drink. He's going to mix 5 parts of orange juice to 2 parts of lemonade. So my ratio would be orange juice to lemonade is in the ratio 5 parts to 2 parts. Now he thinks that he has 300 millilitres of orange juice and 200 millilitres of lemonade. And he needs to figure out what the greatest amount of fizzy drink he can make is. So in order for him to make this fizzy drink, he needs to have the full amount of both. So we can see what we can do with that. So I need to figure out, if I have 300 millilitres of orange juice, how much lemonade do I need? So I make my ratios equivalent, and I think to myself, what do I need to multiply 5 by to get to 300? So I can do 300 divided by 5 to figure that out. I think to myself, how many times does 5 go into 3? 0. So how many times does 5 go into 30? 6. And then how many times does 5 go into 0? 0. So I've times 5 by 60. So what I need to do is multiply 2 by 60 as well, as its equivalent ratios. 2 times 60 is 120. So if he has 300 millilitres of orange juice, he's going to need 120 millilitres of lemonade. So I've worked out how much he can make using the maximum amount of orange juice. Now I want to do the same for lemonade and see whether there's enough. So he has 200 millilitres of lemonade. So I can think to myself, what do I multiply 2 by to get to 200? That would be 100. So 5 times by 100 would be 500. So if he uses the full 200 millilitres of lemonade, he's going to need 500 millilitres of orange juice, which he doesn't have. So therefore that combination we cannot use, and the greatest amount of fizzy drinks he's going to be able to make would be this, because my other option was 500 millilitres of orange juice with 200 millilitres of lemonade. So because he has to mix it in this ratio, he can't just use more lemonade and borrow orange juice out of nowhere. He's used the maximum amount of orange juice. So the greatest amount of fizzy drink is going to be when he uses 300 millilitres of orange juice and combines it with 120 millilitres of lemonade. So it is worded a bit strangely because I guess, yeah, so it's not many people make their own fizzy drinks, but to make a fizzy drink, you mix the orange with lemonade. So he mixes the 300 millilitres with the 120 millilitres of lemonade. So we do 300 plus 120, which gives me 420 millilitres. And that's going to be the greatest amount of fizzy drink that he can make. I'm then told that Shahid has 300 millilitres of orange juice, but he has only 160 millilitres of lemonade. Does this affect the greatest amount? Well, for my thing, 300 millilitres needs to be mixed with 120 millilitres of lemonade. So no, it does not affect the greatest amount, as 120 millilitres is still less than 160 millilitres. So even though he has less lemonade than he thought, he doesn't need that lemonade, he only needs 120. So that's the reasoning for that. Next, I am told that there are 2 rectangles, one that has a side of 8 centimetres and 6 centimetres. and the other one has a side of 12 centimeters and 10 centimeters. Jim says the two rectangles are similar because 8 plus 4 is 12 and 6 plus 4 is 10. Is Jim correct? Well, no, he isn't. And this requires you to understand what similar shapes are. So shapes are similar when each side is multiplied by a common ratio or scale factor. This is kind of complicated language, so I'll explain what I mean. So what that means is if I had this square, well, let's make it a rectangle actually, and that was 5 and that was 7, and this length here was 30. What have I multiplied 5 by to get to 30? I multiplied it by 6. 7 multiplied by 6 is 42. So because each side of the rectangle is multiplied by 6, so it's basically, this rectangle is 6 times larger. That's how I know that it's a similar shape. So shapes are only similar when each side is multiplied by a common ratio scale factor. So what would that be? Well, 8 times by 1.5 is 12, and I don't think you're expected to know that. What they're expecting you to say is they're expecting you to reference that you should be multiplying rather than adding. So that's the key thing. They could have given a slightly nicer thing so that you could prove your yourself on a non-calculator paper, but the key thing is that to find out if shapes are similar, you need to be able to multiply the sides of the smaller shape by a number to get to the larger side. So yeah, the mistake he has made is he has added to find a scale factor rather than multiplied. Okay, next we've got a frequency tree. So the key thing with frequency trees are that each of these little branches or columns need to add up to 80. So let's fill in the information we've been given first. So I'm told that 48 of these people are women. So the total people are 80, and I know that 48 of them are women. Now I know that this branch and this branch are going to need to add up to 80. So what I can do is 80 take away 48, which is going to be 10 take away is 2. So that's going to be 32 to find out how many men there must be. So just like these two little columns needed to add up, over here, all of these little parts are going to need to add up to 80 as well. So let's fill out what other information I've got. I'm told 61 of the 80 people like coffee. So like coffee and like coffee needs to add up to 61. And then I'm told 8 of the men, so 8 of the men do not like coffee. So I'm going to put 8 over here. Now, what I can do is work backwards. So I know that these two that I've underlined in the dark green need to add to 61. I know that these two branches here must add to make 32, because when you branch off, it needs to add up to the previous thing. So over here, 32 plus 48 needs to add to make 80. Similarly, this plus 8 needs to make 32. So if I do 32, take 8, that's going to give me 24. So I've got 24 over here. And then I can use the other person, the other information I've been given, which is that the people that like coffee add up to 61. So I can do 61 take away 24. So that would be 11 take away 4 is 7, and 5 take away 2 is 3. So that would be 37. And then I know that these two branches must add up to make 48. So 48, take 37, 8 takes 7 is 1, so that would be 11. So that's how you fill out your frequency tree. It's kind of like just a problem solving, like filling in the missing numbers kind of thing. And the key thing to remember is to double check that you are right. All of your little columns need to add up to the full amount, and each little branch must add up to where it came from. So that's the frequency tree. And then I'm told one of the people who like coffee is chosen at random. So my probability is going to be out of the amount of people that like coffee. So I'm told that 61 of the 80 people like coffee. So my probability is going to be out of 61. And find the probability that this person is a woman. So how many women are there that like coffee? So I go along the line of women like coffee. That's 37. So the probability would be 37 over 61. This is a slightly harder probability because they've shrunk the probability down. It's not out of the total. The probability is out of the people that like coffee. That's why reading the question is super important. Okay, so in this question, I'm told that Food Mart and Jan's store sell boxes of the same type of breakfast cereal. Each shop has a special offer. So Food Mart has the offer of a 400 gram box having 20% off the normal price, which is £5. And Jan's store, or Jan, has the same amount, 400 grams, plus 30% extra, which has a cost of £5. So we're going to have to do a little bit of comparison here. So at Food Mart, I know that a 400 gram box costs 20% off £5. So the original box would have cost £5, but there's now an offer for 20% off. Now, what I could do, if you're not 100% with money, is turn that into pence to make it a little bit easier. This is a non-calculator paper, so you want to use the tricks of finding 10%. So anytime you want to find 10%, you just divide by 10. So I know that 10% must be 50p, and therefore 20% is double 10%. So I'm going to double that. So 20% is going to be £1 or 100 pence. Therefore, I know that 400 grams at Food Mart is going to cost £4, because £5 take away take away £1 is £4. So here, this box costs £4. Now, at Jan's store, I'm told that 400 grams plus 30% extra costs £5. So I've got 400 grams and I know I've got 30% extra. So once again, let's work out 10%, and the cheat mode to find 10%, you just divide by 10. This is a little trick that you want to remember. So 10% is going to be 40 grams, and 30% is 3 lots of 10%. So I times that by 3. So I'm going to times this by 3 as well. So 30% is going to be 120 grams. Now 400 grams plus 120 grams is 520 grams. So at Jan's store, 520 grams costs £5. So now I need to work out basically which one is the best buy. So the first part of the question was using percentages to figure out what the cost of everything actually is, including the sale. And the next part is to get a comparison. So to decide whether something is better value for money, you either want to work out, for example, the cost of 100 grams and find out which one's cheaper, or for example, the cost of £1 and find out which one gives you more grams. So what I could do here, because it's a non-calculator paper, probably the easiest, honestly, it depends on what your calculator skills are and what you prefer. But the easiest thing would probably be to work out what the cost per pound is. So in Food Mart, if I know that 400 grams costs £4 and I want to get to the cost of working out what a pound is, I'm going to have to divide by 4. So 400 divided by 4 is 100. So I know that at Food Mart, I'm going to spend £1 to get 100 grams. So I want to see and do the same for Jan's store. So I know that 500 grams costs £5, and I want to know what I could get for £1. So what have I done to get from 5 to 1? I'm dividing by 5, so I'm going to need to divide 520 by 5 as well. So 520 divided by 5, 5s into 5 go once, 5s into 2 don't go, so I carry the 2, 5s into 20 go 4. So I know that at Jan's store, £1 is going to get me 104 grams. So that means that I get more for my money at Jan's store, because for the same amount, I get more grams. So my conclusion would be Jan's store, as I get 104 grams per pound versus 100 grams. Your showing is going to support all of that. Okay, next I have to do a rotation. So this is very difficult to do when I don't have the tracing paper. But what you do is you get your tracing paper. So imagine that this is your whole tracing paper. You draw on top of it. So you put your tracing paper on top of the page. You draw in pencil over it, and it tells you to rotate shape A 180 degrees about 1, 0. So you go to the coordinate 1, 0, which is here. You put your pencil on there and you rotate your paper. Now, if your paper looks like this, a 90 degree rotation, okay, is a quarter turn. So it's when you turn your paper once round like that. A 180 degree rotation is when you've turned your paper twice. So once you've turned your paper twice, the coordinates you should get would be 4 and -3, and then 5 and -4, 5 and -5, and 4, -5 as well. So this is what your shape should be like. The key is put your tracing paper on top of it, put your pencil there, rotate it again, and then you might want to, if you're quite new to this, then you probably want to write your coordinates down to the side and then fill them in. But the whole point of the tracing paper is it shows you where your shape should go. Okay, next we've got index laws. So the two key things that we need to know are the law of multiplication, which is that when you multiply indices, so let's say you've got 3 to the power 5 times 3 to the power 3, that would become this. So the law tells you that you add the indices. So when you're multiplying indices, you add the powers. So the law of multiplication is when you're multiplying indices, you add the powers. And then you've got the law of division, which is that you subtract the powers. So we're going to use both of these laws to help us work our way through this. So we've got 3 to the power of 7 times 3 to the power of -2. I'm going to use the law of multiplication, which means I add the powers. So I've got, that would become 7 plus -2. And when you've got a plus and a minus next to each other, that just becomes a minus. So that would be 3 to the power of 7 minus 2, which would be 3 to the power of 5. So that becomes 3 to the power of 5. This is a little bit of a difficult one because it's got a negative indice, but all you need to know is that you do exactly the same thing. You add the powers together, and adding a negative is the same as subtracting. Now, the next part is that this line here, it's a fraction, which means it's a division. So you're essentially saying you've got 3 to the power of 5 divided by 3 to the power of 3. And what do we do when we divide? We subtract the powers, so that would become 5 take away 3, and 5 take away 3 is 2. So you would get 3 squared, and it says work out the value. So the value means work out the actual number. So 3 squared is 9. Okay, next we've got a substitution question. So again, with substitution, it's just always super helpful to actually write out what the algebra means. So we need to work out the value of v. So I know that v squared equals u squared plus 2as, and 2as means 2 times by a times by s. Whenever numbers and letters are next to each other in algebra, it means they're being multiplied. So v squared is going to be u squared. I know that u is 12, so that would become 12 squared plus, and it's helpful to put things in brackets just because you know that this is its own separate thing so that you don't get confused. So I've got 2 times a is -3, and then s is 18. So I know that v squared is going to become 12 squared, which is 144, plus, and then there's a few ways I can do this. Whatever's easiest for you, I would do 2 times 18 is 36 times by -3, and then I just work out what 36 times 3 is. So 6 times 3 is 18, 3 times 3 is 9, plus the 1 is 108. So v squared is going to be 144 plus negative 108, because 36 times 3 is 108, but 36 times -3 would be -108. When you've got a plus and a minus next to each other, it becomes a minus because adding a negative is the same as subtracting. So v squared is 144 minus 108. So then we do that calculation as well. So we've got 144, take away 108. 4 take 8 you can't do. So 14 take away 8 is 6. 3 take away 0 is 0. No, 3 take away 0 is 3. And 1 take away 1 is 0. So you're left with 36. So v squared equals 36. And then we have to do the square root. I know that something squared is 36. So what's the square root of 36? Well, the square root of 36 is 6. So this is quite a tricky one and involves you knowing your square numbers and square roots. Next, I need to make S the subject of this equation. So S is over here. It's attached to 2as. So I've got v squared equals u squared plus 2as. What I want to do when I'm changing the subject is I want to leave the thing that is going to be my subject on that side and move everything else first. So I can just subtract u squared from both sides. So I'd be left with v squared minus u squared equals 2as. Now, if we think back to what happened in the last question, 2as means 2 times a times s. So s is actually being multiplied by 2a. So what I can do is divide both sides by 2a, and then that leaves me with s on its own. So I've got v squared minus u squared over 2a equals s. But once again, this is quite a tricky one. And what you could do is also use a function machine to help you decide what you need to do first. Okay, we now have a percentages problem. So I'm told that a bonus of £2,100 is shared by 10 people who work for a company. 40% of the bonus is shared equally between 3 managers. Then the rest of the bonus is shared equally between 7 salesmen. So let's first work all of that out. So I know that 40% is shared between 3 people. So 40% of 2,100 I'm going to need to work out. So let's start. This is a non-calculator paper. You've got 2,100 is your total. And let's start by working out 10%. Remember, the trick for 10% is to divide by 10. So 10% is going to be £210. And on non-calculator, if you've got a number that ends in 0, you just chop off a 0 to divide by 10. So 10% is £210. I then need to work out 40%. 40% is 4 lots of 10%, so I'm going to multiply by 4. So 210 times by 4. 4 times 0 is 0, 4 times 1 is 4, and 4 times 2 is 8. So that is 840. So I know that 840 is shared equally between 3 managers. So what I can then do is do 840 divided by 3. So 840 divided by 3, 3's into 8 go twice, remainder 2, 3's into 24 go 8, and 3's into 0 goes 0. So 840 divided by 3 is 280. So then I know that each manager gets £280. So manager gets £280 each, and I'm told that the rest of the bonus is shared equally between 7 sales. So the managers get £280 each. I didn't actually need to work out how much a manager gets each, but I did. So I need to work out how much is left over. So I've got 2,100 in total, and then 840 is paid out to the managers. So 0 take 0 is 0. 0 take 4 you can't do. So I don't know why that just disappeared. So that becomes 0. So 10 take away 4 is 6. 0 take away 8 you can't do. So that becomes a 1. 10 take away 8 is 2. So you're left with 1,260 that is shared equally between 7 salesmen. So let's just write up all of our key findings. I know that 1,260 is split between 7 salesmen. So let's do that. So 1,260 split into 7. 7's into 1 goes 0. So 7's into 12 go once, remain to 5. 7's into 56 go 8, and 7's into 0 go 0. So that means that originally the salesman gets £180 each. Now it said if the bonus is shared equally between all 10 people, I will get 25% more money. So the way that they've done it, the salesman currently gets £120 and £180 each. If it's shared equally, 2,100 divided by 10, we already know is 210. So he thinks that he would get 25% more money. Well, he currently gets £180, 25%. So another shortcut to work out 25%, you divide by 4 because 25% is a quarter. So 180 divided by 4, 4 is into 18, go 4, remainder 2, 4 is into 20, go 5. So 25% more money would be £45. So 25% is 45. 180 plus 45 is 5, 12, 225. So he's saying that if the bonus is shared equally, he would get 25% more. Well, no, if the bonus was shared equally, he would get £210, which is £30 more, but to get 25% more money, he'd actually need a bit more. So you just want to have all of your numbers supported. There's a lot of division, a lot of multiplication in this one, and just a knowledge of percentages is important. So having those key shortcuts are important. Okay, so in this question, I'm told that it would take 120 minutes to fill a swimming pool using water from 5 taps. And I'm being asked how many minutes it would take to fill the pool if only 3 of the taps are used. So 120 minutes is how long it takes for 5 taps to fill a swimming pool. So what I want to do is think to myself, okay, so it takes 120 minutes for 5 taps to fill it. So I'm going to see if I can work out how long it would take for 1 tap to fill it. So 5 taps, it's obviously going to get filled a lot quicker because there's more water coming in at the same time. So this is an inverse proportion question. So with inverse proportion, whatever you do to one side, you do the inverse operation to the other side. So how do I get from 5 to 1? I divide by 5. So what I need to do on this side is times by 5. The way to recognize if it's an inverse proportion question is to think to yourself, okay, as one quantity increases, does the other quantity also increase? Or as one quantity increases, does the other quantity decrease? So for instance, if there were more taps filling up the swimming pool, we'd expect the time to be less because more water is coming in, so the volume is getting filled up quicker. So 120 times 5, if I did 12 times 5, I know that's 60. So 120 times 5 is going to be 600. So just 1 tap on its own, it would take 600 minutes to fill. And now I want to work backwards and find out how long it would take for 3 taps. So what have I done? I've multiplied 1 by 3 to get to 3. So I'm going to have to do the inverse on this side. I'm going to have to divide by 3. And 600 divided by 3 is 200. So 3 taps is going to take 200 minutes. Now it's asking me to state one assumption I made in working out my answer. Well, I'm assuming that all the taps have the same pressure. In other words, pour out the same amount of water. Because, for instance, if you had like a really slow leaky tap versus a really fast gushing tap, then obviously that one's going to fill it up quicker. You're assuming that each of the 5 taps are pushing out water at the same speed. So that's the assumption that we're making. If they're all filling it up at different rates, then this, obviously I can't use this to work it out. Okay, so in this question, I'm told that a plane travels at a speed of 213 miles per hour, and I need to work out an estimate for the number of seconds a plane takes to travel 1 mile. So the really important thing here is, first of all, that we're being told to estimate. When you're estimating, you generally round to one significant figure, unless it would make your calculation a lot easier if you rounded it to something else. So the speed is the only piece of information we've been given, so that's what we're going to round. So the speed is going to become 200 miles per hour. Next, the important thing that you need to remember is that whenever we're dealing with speed, distance, time, we're generally dealing with units of an hour. So we've got miles per hour. So the fact that the question is asking me to estimate the number of seconds is something that I'm going to have to bear in mind. So first of all, let's write out our equation. I know that speed equals distance over time, but in this question, I'm being asked to work out the number of seconds, which is time. So the distance is 1 mile, the speed is 200 miles per hour, and time is what I'm trying to work out. So I rearrange that equation. So time is equal to distance divided by speed. And time is given to me as a unit of an hour. So time is going to be distance, which is 1 mile, divided by 200. So to work out the number of seconds, I'm going there's a few things here. First of all, it's given to me as a fraction of an hour, but so it's 1/200th of an hour, but it wants me to work out the estimate in terms of seconds. So I need to think of how many seconds there are in an hour. Well, I know that in an hour there are 60 minutes, and in a minute there are 60 seconds. So I'd do 60 times 60, 6 times 6 is 36, and add on the 2 zeros. So there are 3,600 seconds in 1 hour. So you might know this already. If not, you know that in each minute there are 60 seconds and there are 60 minutes in an hour. So you do 60 times 60. So I know that this has been given to me as a fraction of an hour. And I know that in 1 hour there's 3,600 seconds. So I'm going to have to do 1 over 200 times by 3,600. So to turn any number into a fraction, I just write it over 1. So that would become 3,600 over 200. I can just start by dividing both by 10. So that becomes 360 over 20. Divide by 10 again is 36 over 2. And 36 divided by 2 is 18. So this is quite a tricky question because it requires quite a lot of steps to be taken, but it would take you 18 seconds. And the trick is just to remember that whenever we're dealing with times, so in here the speed is given to me in miles per hour, so the time is 1/200th of an hour. So you turn that into seconds by multiplying by 3,600. And what did I do? So is your answer to part A an underestimate or an overestimate? So what I did is I rounded the speed down. I rounded the speed down. So therefore, how does that affect it? So I'm dividing. So just separately here, the time would be 3,600 divided by 213 if I hadn't rounded down. But what I did is I rounded down to 200. And let's just think what happens when we divide by a smaller number. Let's take an easy example. So let's say 10 divided by 5 is the larger number. 10 divided by 5 is 2. If I divided by a smaller number, 10 divided by 2 is 5. I end up with a larger answer. So here, this is my larger, this is my smaller because I underestimated. So I'd end up with the smaller or underestimate here. And over here, I'd end up with an overestimate because it's when I'm dividing by a smaller number, I get a larger answer. So I rounded that speed down. So therefore, I divided by a smaller number and would have ended up with an overestimate. So the reason it's an overestimate is because you're dividing by a smaller number, and if you divide by a smaller number, you end up with a larger answer. Okay, so in this question, I'm being asked to solve the simultaneous equations. So simultaneous equations are when you have two equations, both have an x and a y variable, and the key to solving them is by making one of those variables the same. So I can either choose to make my x's the same by multiplying this equation by 5, or I can make my y's the same by multiplying this equation by 3. I think what I'm going to do is multiply by 5. But you can obviously do whatever you want to. So I've got 5x plus y equals 21. And then I've got x minus 3y is 9. If I multiply this equation by 5, I'd then be ending up with 5x as well. So 5 times x is 5x, minus 3 times 5 is minus 15y, and 9 times 5 is 45. Now, what I want to do once I've got one of my variables to be the same, I need to decide whether I'm going to add or subtract the equations. And you do that by circling your variables and thinking, okay, if I did 5x plus 5x, what would that become? If I did 5x minus 5x, what would that become? Well, 5x plus 5x is 10x, 5x minus 5x is 0. So obviously I'm going to be subtracting because you want to eliminate one of the variables. Now, I know that I'm going to be subtracting, so what I can do is make my life easier and just write this equation underneath, because then what happens is I'm subtracting 21 from 45 instead of subtracting 45 from 21. I'm just making my life easier. It just means I don't need to deal with that many negative numbers. So I've got 5x take away 5x is 0. Then I've got minus 15 plus 1, or minus 1 rather. So minus 15 here minus a positive y is going to give me minus 16y. And then 45 take away 21, 5 take away 1 is 4, 4 take 2 is 2, so I'll be left with 24. So I know that minus 16y is 24. Now what I could do is multiply by negative 1. When I multiply both sides by negative 1, it just means I can switch the signs, so I'd be left with 16y is negative 24, because then I have a positive variable. So 16y is negative 24. I'm going to have to divide both sides by 16. So y is going to be minus 24 over 16. It's a non-calculator paper, so I'm just going to have to simplify this. So I've got minus 24 over 16. If I divide it by 2, I'd be left with 12 over 8. Divide it by 2 again, I'd be left with 6 over 4. Divide it by 2 again, I'd be left with 3 over 2. So that would be minus 1.5. So I know that y is minus 1.5. So I've worked out what one variable is. Now I need to do exactly the same. I need to substitute y as negative 1.5 into one of my equations. Now the easiest one would probably be this one, because it's just one lot of y. So I've got 5x minus 1.5, because it's just one lot of y, must equal 21. So therefore, I'm going to need to add 1.5 to both sides of the equation. So 5x equals 22.5. And then I'm going to need to divide both sides by 5. So x is going to be 22.5 divided by 5. So 5's into 2 don't go, so 5's into 20 go 4, remainder 2, and 5's into 25 go 5. So x is going to be 4.5. So to solve my simultaneous equations, I need a value for x and a value for y, and the value of y is minus 1.5 and the value for x is 4.5. Okay, next I've got quite a tricky question involving circle parts. So I'm told the diagram shows a square ABCD. So it's a square, that's important because it means that all of the sides are going to be the same length. So this is going to be 20 as well. It also shows a semicircle and an arc of a circle. I'm told that AB is the diameter of the semicircle. So I know the diameter of the semicircle is 20 centimeters. And I'm told that AC is an arc of a circle with centre B. So it's complicated language, but if this is the centre of the circle, then this must make AC a quarter of a circle, because the radius is going to be here. So this must be the radius of that other bigger circle. I need to show that the area of the shaded region divided by the area of the square is pi over 8. So there's quite a lot of stuff that I'm going to need to do here. So first of all, how do I work out area of a shaded region? What I do is I do the total area, take away the unshaded parts. So what I'm going to have to do to work out the area of the shaded region, which is this part here, is work out the area of the square, take away the area of the semicircle. And actually this is quite a hard question, but let's give it a go. So step 1, let's work out the area of the square. The area of the square is, I know that it's 20 centimeters by 20. So 20 times 20, 2 times 2 is 4, add on the 2 zeros, so that's 400 centimeters squared. The area of the quarter circle, so actually, there's an easier way to work out the area of the shaded region. I work out the area of the quarter circle. So imagine this part is a quarter circle, and then I subtract the area of the semicircle. So step 2, the area of the quarter circle. So it's a quarter of a circle, and I know that the radius is 20 centimeters. So how do you work out the area of a circle? Area is pi times the radius squared. So the area of a quarter circle is going to be pi times radius squared divided by 4. So the radius of this quarter circle is 20. So I'm going to do pi times 20 squared divided by 4. So 20 squared is 400. So that would be 400 pi divided by 4. So therefore the area of the quarter circle is going to be 100 pi. So 400 divided by 4 is 100. So that's the area of the quarter circle. Then we can work out the area of the semicircle. So once again, how do you work out the area of a circle? Area is pi times radius squared, but this is a semicircle, which means half a circle. So I'm going to do pi times radius squared divided by 2. So the radius squared, the radius, if the diameter is 10, the radius is going to be 10 centimeters because the diameter is from one side to the other, whereas the radius is from the center to the outside. So pi times 10 squared divided by 2, 10 squared is 100. So that would be 100 pi divided by 2, which is 50 pi. So the area of the semicircle is going to be 50 pi, and these are all centimeters squared, but I'm just not writing them in. So I need to show that the area of the shaded region, so the shaded region over here is going to be the quarter circle, take away the semicircle. So let's do that as well. So area of shaded region is going to be the 100 pi, take away 50 pi, which is 50 pi centimeters squared. So that's the area of this. The shaded region is 50 pi centimeters squared, and the area of the square is 400. So what I'm going to have to do is say area of shaded region 50 pi over 400, and I'm going to simplify this. So if I divide it by 50, simplify the fraction, 50 divided by 50 is pi, 400 divided by 50 is 8. So 400 divided by 50, you would have ended up with 40 divided by 5 if you divide it by 10, and then 40 divided by 5 is 8. If you can make that connection. You could also have divided by 10 first. So if you divided by 10 first, let's say 50 pi over 400, let's divide by 10, you would have ended up with 5 pi over 40, and then 5 divide by 5, so you would have ended up with pi over 8. So that's how you show that. This was a tricky question, especially the shaded part, but it's about realizing that, okay, this is a quarter of a circle and you're subtracting the semicircle from it. Okay, so I'm told that Amina has 2 bags. In the first bag, there are 3 red balls and 7 green balls. So that means that there's a total of 10 balls in total in the first bag. And in the second bag, there are 5 red balls and 4 green balls, so 9 balls in total. So all my probability for the first bag is going to be out of 10. And for the second bag, it's going to be out of 9. Amina takes at random a ball from the first bag. She then takes at random a ball from the second bag. And I need to complete the probability tree diagram. So the first thing, with probability trees, your probabilities must add to 1. So here you've got 3/10, so this is going to need to be 7/10, because with probability trees, the events are mutually exclusive, which means only one of them can happen at one time, and their probabilities must add to 1. So I've got 7/10 over here. Now for the second bag, there's 5 out of 9 red balls and there's 4 out of 9 green balls. So I just fill that in over here. So that's how I fill out my probability based on what's happening. I know that for the first one, they're all out of 10. And for the second, it's out of 9. And that's all I need to do for this probability tree to fill it out. I then need to work out the probability that Amina takes 2 red balls. So the probability she takes a red ball for the first one would be 3/10. And the probability she takes another red one would be 5/9. So when we're using a probability tree to work out the probability of something, you literally go along the branches and you multiply to get the result. So 3 times 5 is 15, 10 times 9 is 90. So the probability that she gets 2 red balls is 15/90. And then the last question, I'm told that the size of each interior angle of a regular polygon is 11 times the size of each exterior angle. Work out how many sides the polygon has. So this is quite a tricky question. It relies on you knowing that you've got the interior angle and then you've got the exterior angle. And the interior plus the exterior always sum to make 180 degrees. Because if you think of it, you've got your polygon here. Doesn't matter how many sides it has. The way we work out the exterior angles is we continue them along a line. So therefore that's your exterior, that's your interior. And we know that they need to add to make 180 degrees. It says the size of each interior angle is 11 times the size of each exterior angle. So let's say I've drawn the diagram wrong in terms of sizing. But if this is the interior angle, it's 11 times the size of the exterior angle. So we could call the exterior angle X, just because when we don't know the value of something, that makes life so much easier. So the interior angle would be 11 times by X, which is 11X. So in total, I know that 11X plus X must add up to make 180 degrees. So 12X must equal 180 degrees. So to work out what X is, I do 180 divided by 12. So what I could do is simplify. So if you know how to do long division, that's great. But otherwise, we're going to have to simplify. So you've got 180 divided by 12. We can start by dividing by 2. So that would become 90 divided by 6. We could divide by 2 again. And then that would become 45 divided by 3, which you might be able to do in your heads. If not, then you use division. So you've got 45 divided by 3. 3's into 4 go once, remainder 1. 3's into 15 go 5. So that would mean that X is 15 degrees. So I know that the exterior angle of the polygon is 15 degrees. And that the interior angle would be 11 times 15, or just 180 take away 15. Now, how do you work out the number of sides something has? So 360 degrees divided by the number of sides tells you the size of an exterior angle. So similarly, if you did 360 divided by the size of an exterior angle, you'd be able to figure out the number of sides. So now I need to do 360 divided by 15. So once again, I can simplify it. So divide by 2, or no, let's divide by 5, because then we'd get decimals. So if I divide that by 5, that would be over 3. And then 360 divided by 5. 5's into 3, you can't do. 5's into 36 go 7, remainder 1. 5's into 10 go twice. So that would be 72 divided by 3. And once again, you can do that. So 72 divided by 3, 3's into 7 go twice, remainder 1, 3's into 12 go 4. So that would be 24 sides. So this was quite a tricky question because it involved quite a lot of division, simplification, and knowing what the rules are for angles in a polygon. But yeah, that's the end of the exam. So thank you for watching and good luck with the rest of your revision.